Hi, my name is Berkay and here I am with another video. In this video, I will going to show you how to deal with a signal that is irregularly sampled, noisy, and has a lot of missing data points. So let's start. First, let's load our data. And as you can see, this data has four components. One is original signal, other one is original time, next one is signal, and last one is time. And let's see our signal. So as you can see, this signal has two large noise spikes, and when you zoom in, you can notice that there are a lot of missing data points in this signal. And when you zoom in even more, you can notice that this signal is irregularly sampled. There are a lot of time differences between sampling rates, so we will going to fix them. And as you can see, at the end of the video we will have a signal that look like this orange signal. First, we were going to find and deal with these missing data points, and after that we are going to remove noise from this signal, and lastly we were going to resample this signal. And as you can see in here, I have created some parameters. Endpoint is equal to length of my signal. I have copied twice my signal in here, and after that I've created a data parameter and an increment parameter in here. So in here, as you can see, this is a more of a traditional way to deal with enhance, and this is just a function. So first, I have created a while loop to look for each data point in my signal. Then I have created an if statement and use isNaN function to find nans in my signal. And if that data point is an nan, it will going to uh, increment parameter by 1, and it will going to look the next data point. After that, if it is a nan again, it will just going to go back and increment parameter by 1 again until it is not an nan. And after that, it will going to take average of previous data point and the next data point, and it will going to assign that to that nan value. And after that, it will going to reset increment parameter again, and lastly it will going to increase data by 1. And if our data is not an nan, it will just going to increase data by 1. And let's see. As you can see, I have interpolated those missing points and there are none left in my signal. And in here, I have used fill missing function to find and deal with nans. First, I have specified my signal and my method, and it's move mean method, and my window size. So what fill missing do is it will going to calculate the mean of my signal and assign a value according to that mean. And let's plot them together. And as you can see, it is almost the same, but if you zoom in, you can see that there is spikes in fill missing function graphs. So you might think that fill missing isn't correct, but this is wrong because we are interpreting our signal. So we don't know what is really happening there. We are just guessing it. So my way and this function way is both correct and wrong at the same time. We don't know which one is correct or not. So in here, I'm going to remove those noise spikes, and first I have specified this that noise windows in here, first one in here and second one. And after that I have created a for loop, and I am going to use spectral interpolation to remove these noises. But first I have removed noise by assigning enhance to those data points. So what spectral interpolation do is it's basically this one. It will going to take Fourier transform of previous windows of my data point and post window of my data point, and it will going to add them together and divide them by 2. And after that it will going to take inverse Fourier transform and detrend it and assign to edit data. Now I have detrend my uh, data, but I need to align it to my signal. So I have created a linearly spaced numbers from 0 to 1 and times basically, so this is basically difference from second noise points to first noise points. So this is basically the slope of my window, and I have added the immediately before the first noise point in here. So I have added them together to align my window to my signal, and after that I have created a filter signal parameter and basically filtered my signal. And for the second iteration I have updated my copy signal in here, and let's see. So as you can see, I have removed noise from my signal and interpolated those removed windows by using spectral interpolation. And lastly, we are going to sample our signal. I will going to upsample it. So I have used graded interpolate function for it. So what this function does is it will create an object R, and it will going to use sprime method for it. So I have specified time vector and my filter signal and its method. So I have designed a new sampling rate and created a new time vector. And after that I have specified new time vector in here and created a new signal. Now I will going to plot my original signal and my new signal together. And as you can see, it is almost same. There are few differences between those signals, but it is almost same. And this is it. Thank you for listening to me.